Hello, now we're going to have a look at distance versus time graphs in a more real-life type context. Effectively, these are just questions that are told as stories. There's no practical difference between them and anything else that we'll look at, except that it will have a little bit more English that we have to read to follow along with the story that they're giving us. So James cycles to the shops and back home, and his journey is traced out on this distance time graph. So he starts out at home down here, and he cycles away from home until he gets to here. His distance away from home doesn't change for a little while, and then he travels from here back down to a distance of 0 away from his house. So he was away from his house, and then he wasn't. So this means this is his journey back to the house. As our line drops back down to a distance of 0, we're getting closer and closer back to our house. So how far away is this shop? Well, we start out at a distance of 0 away from our house, so we're at our house, and then we keep cycling until we are 5 kilometers away from our house. So that means, logically, that our distance for our shop is 5 kilometers away from our house. And this is what I mean by this being a story. We have to be able to interpret our graph. We have to be able to look at our graph and say, well, I was at home. I have a distance of 0 away from my home, so I'm at my home. I move away for a while. I get further away from my house, and then I stop getting further away from my house. Well, the point where I stopped going further away from my house should be when I got to my other destination. I'm no longer moving. I'm no longer traveling. I am 5 kilometers away from my house. So that is where our shop must be, because that's where we were traveling to. Now, what speed did he cycle to the shops at? So what was his speed when he was traveling to the shops? So we're dealing with this area here where we were at home and we got to the shops. Well, our speed, we know in a distance time graph, this is only true for a distance time graph, our speed would be equal to the slope of our line, which is equal to rise over run. So what is our rise from here to here? It's going to be from 0 to 5. So the difference would be from 5 minus 0. You can just write 5 if you like. And we're going from 0 to 2. If we go up here, this point here would be at 2, 5. In the door 2, up the stairs 5. So we're going from 0, time of 0, to time of 2 minutes. So it's going to be 2 minus 0, so it's just 5 over 2. When we put that into our calculator, we're going to get 2.5. And what's our units going to be? Well, our distance is in kilometers, and our time is in minutes. So kilometers per minute. Now, how long was he in the shop? Well, James cycled to the shop. He stayed still for a little while, and then he came back home again. So the time when he was standing still, relatively speaking, obviously he was moving around the shop, but at the time when he wasn't moving a big distance back and forth away or toward his house, must have been the time he was in the shop. So that was from 2 minutes up to 5 minutes. This point is at 5, 5. In the door 5, up the stairs 5. So from 2 minutes up to 5 minutes was when he was in the shop. So 2 minutes minus 5 minutes is going to give us 3 minutes. He was in the shop for 3 minutes. And how fast did James cycle home? Well, we know again how fast means speed, and we know that speed is slope on our distance time graphs is equal to our rise over our run. Well, we start out at 5, 5, and we end up back down here. Now, what would this be? This would be in the door 10 and up the stairs nothing. So this would be either point 10, 0. So, what's our rise? We start at 5 and we end up down at 0. So our difference there would be we've gone down by 5. So our rise is actually going to be going down by 5. And our run is going from 5 to 10. So the difference there is going to be 10 minus 5. So our difference is minus 5 all over 5. We put that in the calculator and we get minus 1. Now this is the slope. This is perfectly mathematically true. We often don't talk about negative speeds at junior cycle. We will in Leaving Cert, but at junior cycle we often don't talk about negative speed. So if you wrote down speed was equal to minus 1 kilometers per minute, you would get full marks for it. But we don't usually deal with that in junior cycle. Usually we say he was traveling back home at 1 kilometer per minute. And we don't worry too much about the sign. But this is technically more mathematically true. So it's good if we can write it this way, but if you wrote down 1 kilometer per minute, we'd be okay as well. So that is what we need for our